Hello viewers, I'm Kausalya. Today we are going to solve problems related with the star network. The problem is an unbalanced 4-wire star connected load has a balanced voltage of 400 volt as shown in figure. The loads are Z1, Z2 and Z3. Find line currents, current in the neutral wire, the total power. So here, since you see this is an unbalanced network, that is the load is unbalanced and it is a 4-wire system. So what is your fourth wire? It is our neutral wire, right? So apart from RYB, that is a neutral wire. So here we need to calculate the current in neutral wire and finally the total power, right? So the first step is here. I'm converting these impedances in rectangular form to polar form. So as we already know, in a star network, the given voltage is our line voltage, right? So here you see this 400 volt is our line voltage. So we are finding the phase voltage. So this is 400 by root 3, right? So this is your diagram, right? This is your star network with the neutral wire and RYB, right? So Z1 pi 1, sorry, this will be your Z2 pi 2 and this is your Z3 and pi 3, right? So now we are taking our VRN as reference. So here the reference is 230.94 with 0 degree, right? So VYN is, again, that is all the three wires, right? RYB have or displaced individually by an angle of 120 degree. Therefore here 230.94 with minus 120 and finally VBN is 230.94 with an angle of minus 240, right? And now we are going to find the value of the line currents, right? So here the line current value is given by VRN by Z1, and here regarding this star connected network, the value of line current is equal to phase current, right? So here the phase voltage divided by the respective impedance will give the value of the IR, IY and IB, right? So IR is nothing but VRN by Z1. We know the value, just substitute and here is our answer. Similarly for IY, it is VYN by Z2 and here IB VBN by Z3, right? So here just substitute the values and our answer is in polar form, right? Now the next thing is, that is first part of the problem is over. We have calculated the value of line currents and here again the thing is the line current is equal to phase current in case of a star network. So with the help of phase voltage, we are finding the phase current. The phase current in turn is equal to the line current, right? Now the next thing is we are going to find the value of neutral current, right? So here the neutral current is nothing but it is given by IN is equal to minus of IR plus IY plus IB. So here just now we have calculated the values of R, Y and B. So just substitute it over here, right? And here the final answer is 36.69 with an angle of 33.30 degrees, right? And here this is just a pictorial representation of how the different values are represented in phasor form, right? So here, as we all know, the voltages are displaced from each other again by an angle of 90 degrees. Similarly, the current also, right? So VRN, VYN and VBN, the angle between them will be 120 degrees, right? And here the next thing is R, Y and B here, right? So here the neutral current is, that is depending upon the angle, here I have represented the neutral current. That is, you see, just initially we can easily draw this VRN, VYN and VBN. Even it will be better if you have a protractor to measure and keep the angle, okay? This diagram I have drawn using a protractor, right? So the next thing is the value of IN, you see the IN is with 33.30 degrees, right? Therefore, this IN occupies the place over here, right? That's it. That is no necessity that it should be drawn exactly with the help of a protractor. If you draw with a protractor, it will be better. That's it, right? Even you can draw with your free hand. No need of protractor. Power. So power in R phase is given by, the general formula for power is I square R, right? So here the value of IR multiplied by this R. So this gives an answer, and similarly for Y phase and similarly for B phase, right? So the total power absorbed by the load is, so here you see it is 10344.41 watts, right? So here we are saying it as an unbalanced network. What is the reason why we are saying it as an unbalanced thing? Because here the value of load impedances are totally different. That is, for R phase we are having an impedance value, and Y phase we are having different, and similarly for B phase we are having different values. Due to the different value of load impedances, automatically the value of current will differ, right? So here you see the value of IR is 25.83, IY is 46, and IB is 9. These value of current differs because of the difference in the impedances or the load which is connected, right? So this is known as an unbalanced network because the value of impedances in each phase is different. Because of the difference in impedances, the intake of current is different, right? And finally, here the total power absorbed by the load, just we have to add. And here the final answer is 10344.41 watts, right? So this problem gets over here. We will proceed with next one. A star connected load with a neutral isolated has impedance of ZA, ZB and ZC. So here this indicates that this is a 3-wire network, right? Because the neutral is isolated. There is no neutral. The supply voltage is 230 volt ABC system. Okay, this denotes your phase sequence. So here taking EBC as reference. Okay, this is the order how the system is, but here we are taking BC as reference. Find the line currents and the voltage across the load impedances, right? So here this is your given star network. It has 3 impedances, ZA, ZB, this is your ZA, and this is your ZB, and this is your ZC, right? So here we are going to find the value of line currents, right, and the voltage across the load impedances. So here the line currents are IA, IB and IC. Now this star network is converted into an equivalent delta network over here, right? So this is your equivalent delta network. So the impedance between your A and B is ZAB, B and C is ZBC, and C and A is ZCA, right? So that's it. So here we have to take EBC as a reference. So therefore EBC is equal to, which is 230 degree with 230 magnitude with 0 degree. So what will, here we start with BC, right? Then the next thing is CA, then finally AB. So 230 with minus 120, and here 230 with plus 120 or minus 240, right? So these are all the values of voltages. Now the next thing is we are going to convert this star network into delta network, right? So this is one method of solving, right? Even you can use Millman's theorem, or even we can use loop method, okay? That is, we have to apply KVL. So first we will see this method. So converting star to delta. So when you convert the star to delta, this is your formula, right? To find ZAB, the formula is ZA into ZB plus ZB into ZC plus ZC into ZA divided by ZC. Similarly, for ZBC we have this, and for ZCA we have this. In all the 3 cases, you see the numerator remains the same. So first we are going to calculate this numerator value. So here ZA into ZB, right? Again we have converted this in rectangular form. Similarly ZB into ZC and ZC into ZA, right? So the next thing is we have to add all these things. So when you add, this is in, the answer is in rectangular form, and we have converted this in polar form, right? So now just substitute the values. So ZAB, ZBC and ZCA, right? So here after substituting, we are getting the answer like this. Now the next thing is we are going to find the values of the current, right? IBC, ICA and IAB, that is, so the current flowing through this line, it is nothing but IAB. through this is IBC, and through this is ICA, right? So here IBC is EBC by ZBC, right? So EBC we know the value, and the value of ZBC just now we have calculated here, right? So just substitute it, and again we are having an answer in polar form. We are converting that to rectangular form, right? So similarly for ICA, ECA by ZCA, and IAB, EAB by ZAB. Now we have calculated the values of the currents, right, that flows in the delta path. But here what we actually need is IA, IB and IC. Therefore here we are going to apply our Kirchhoff's current law, right? So when you consider this node, right, what are the currents that flow towards the node? IA and ICA are the currents that flow towards the node, and IAB is the current that flows away, right? Therefore IA plus ICA is equal to IAB, right? So this is what I had written here, but what we need is we need IA. So IA is nothing but IAB minus ICA. We know all the values, so just substitute it and find the answer. Similarly, when you look at the other node, when you look at this node, right, what are all the currents that flow towards this junction? IB and IAB, and IBC is the one that flows away. Therefore, IB plus IAB is equal to IBC. So IB plus IAB is equal to IBC. So just substitute it, and here is your answer. And similarly, when you consider the other node, right, so IC plus IBC will be equal to ICA here. So again just substitute it, and this is your answer. Now we have calculated the value of the line currents, right? So the next thing is, this is your IC, right? So we have to find the voltage across the impedances, right? So how to find the voltage across the impedances here? So voltage across ZA, it is nothing but I into Z. We know IA, right? Just now we have calculated, right? You see, this is your value of IA. So just substitute it, IA into ZA. Similarly, IB into ZB and IC into ZC, right? So here comes the end of this video as well as this problem. Here the main thing to be considered here is, if you make a single error in the first step or initially, then it will have a huge impact in all the answers that arrives at the end, right? For example, you see, if you didn't find the correct values of ZAB, ZBC and ZCA, what happens? It impacts your current IBC, ICA and IAB. This in turn affects your line current values, right? So again, this value of line current, they will affect your voltage drop across your different impedances. So always be careful while solving these type of problems, right? So take enough time to check whether the answers you have find out are correct initially, okay, starting from your step number 1, right? That's the thing. The remaining things are quite simpler, okay? The basic fundamental formulas are applied here. So if you have any doubt, let me know in the comment section. Thank you.